And this is the alpha lesson continued. So let's look at this picture. You have these two curves. It's user-friendly. You're in the first quadrant. You good? So you have y equals x squared and y equals 2x. And you're going to revolve it around the y-axis, not the x-axis. You got to listen to this. You have, before you start writing or putting stuff in your calculator, you need to slow down and make sure you understand what's being asked. Because if you go around the wrong axis, you can do all the calculus correct and get the wrong answer. And if it's a multiple choice, you can be sure the College Board would put that as one of the choices. So we're going to go this way, around the y-axis. And this is really, I mean, the graphics on these are really helpful. So what have we got here? We have this washer. Can you picture this washer? It's going to be dy. Make sense? Because you're going to have a hole in this. When you rotate this thing, you have this hole in here. Everybody good? So how do we do this? It's pi r squared. Subtract pi little r squared. That's what you have in a washer. Because a washer looks like this. Where this is big R. And if you did pi r squared, it would give you the surface area of that big picture. Then this is little r. And if you did pi r squared to this thing, it would give you the inner circle. And when you subtracted the inner circle from the outer circle, that would leave you the surface area of the washer. So that's where pi big R squared subtract pi little r squared comes from. Then what? We're going to multiply that by how thick it is. And in that picture, the thickness is dy, because these washers are stacked vertically. Then we're going to add them all up from the y limits. So what did they do? Well, they just factored out the pi. You don't have to. So now what? If we're going to do the problem dy, we have to write the function in terms of y. We have to write what x equals in terms of y. So this curve is y equals x squared. We take the square root of both sides, and we get the positive or negative root of root y. But we're only interested in the positive root. And we get y equals 2x, so x equals y over 2. So what happened? If you do the problem dy, the question has to be given to you as what x equals, or you rewrite the question. And you have to use the y values for the limits. Those are the mistakes that people make when they're careless, okay, when they're in a hurry. Like personally, I honestly think this paper is so helpful, and that to communicate this material, I think you could be tutoring other people. You could be tutoring, we're not through it yet, but you could be tutoring the kids at AB, you could be tutoring kids at other school, because it's conceptually, it's a challenge to understand volumes. So what happened? we're going to do right subtract left. So the outside radius is the curve. The curve is outside the line. Right take away left. So here's the pi. There's big O, which is really what? It's root y take away 0. Because this outside radius, that's y equals x squared, so it's x equals root y. So what's the outside radius? Root y take away 0. They didn't write take away 0. I think you should. That's big O. What's little r? The line. Y take away 2, take away 0. Pi, big R squared, take away little r squared, and the limits are the y values. So the y values are the height. It goes from 0 to when they meet. Where do they meet? They meet at the point 2,4. So the dependent value is a 4. And what? Just square both terms. Bring the pi outside, which again doesn't matter. Now what? Well, from here to here, this is the power rule reverse. You can't forget the anti-differentiate. Which gives you that. Now, think about that question. That is a non-calculator exercise. That problem is like a dinosaur. But that used to be on the AP test every year. And then in the last 5, 6 years, they've gotten away from it because there was an audit done and they were told, College Board was told they were too predictable. Well, great. They were too predictable in a good way because people could, it's just hard to get your mind around. And then people would figure it out and they would look forward to getting a question on the AP test and the College Board tries to disguise it. But, you know, whether it's on the AP test directly or just part of some multiple choice, it's still something that you want to understand moving forward. Walking into Calc 3, you want to understand volumes. Now, this, ready, on this PowerPoint is really what I gave you in the purple paper. So you're not going to need to write this down. And what he's saying is, you know, there's just too many balls in here to say, he's saying pi, big R squared, take away little r squared, this pi is being distributed over that from those limits. This is dx, so a and b would be x values. It could be dy, probably just dim as dy. Now, this is why we wanted to do this, because this is what this slide, because this is more often what the question looks like in math. We're going to revolve it around something other than an axis. So remember when I told you that really what you should write is root x take away 0. Well, here you're going to say why. You're going to see why you would do that. Because they're going to take this and rotate it about the line x equals 2, which would look like this. Too fast. There's the picture. See, you didn't go towards the axis. The y-axis, you went away from it. But you still have that washer there. So what have we got? The same things we had before. But we're going to do the same thing. This is how it's different. We're going to do right, take away left. So the outside radius, right, take away left, would be the line x equals 2. And it's going to be 2, take away that line. 2, take away y over 2. And the inside radius is 2, take away the curve. So when you set this up, look what you have. You've got this thing squared, subtract that thing squared. Because in the last problem, those 2's were zeros. So they didn't affect the calculation. And here they're not zeros. Well, this is it. Ready? The rest of this is busy work. We can do it. What's happening here? Lattice. Once you expand the lattice, then you have to do the power rule in reverse. Then you have to substitute the values. So everything is spinning your wheels unless this line is correct. And that's what you're trying to see, that the line is other than an axis. So we're not subtracting 0. We have some line, but we're still being consistent. Right, take away left, or upper, take away lower. There's the lattice, it gives you that. There's the power rule in reverse. Right, and there's the answer. But the answer, like, who cares about the answer? This is what matters. This line right here, which is pi, the limits are the y values, right take away left, squared, the outside radius, which is the vertical line take away the line, subtract the vertical line take away the curve. Let the line x equals 3.
What if it said y?
Oh, what if it said y? You won't get something in the middle of it. You could rotate it about the line y equals 4, or about the line y equals 0, but they won't have you rotate it for something inside. All right?
You never have to like rotate it over with the kind of in your function.
The diagonal line? No. Not in this course. Okay, so the whole point is this. That's why the paper's here to help you. It is. If it's dy, it's going to be right, take away left. If it's dx, it's going to be upper, take away lower. But that's summarized on this paper, because I get it. I know that this is conceptually challenging. This is made for spatial thinking. This is made for people that prefer geometry to algebra. Well, they're not in the majority. If you're a linear thinker like I am, you need an organizational approach to attack these problems. So, we are going to go to an FRQ. Now, before we go there, we got a chat here. Ready? How would you do that problem dx? You wouldn't do it dx, because that wouldn't answer the question. Because if you tried to do this problem dx, you would have this cut that would be perpendicular to the x-axis, and that's not what you're looking for. You can't say all these problems are interchangeable, dy or dx. So before we go to the FRQ, I just want to remind you of something. I go here. There are PowerPoints for the disk method. Ready? Problem 29. In the homework, there's 4 parts to it, A, B, C, D. I did that problem and put it on a PowerPoint, all 4 components, A, B, C, D. That's the first problem you should focus on when you're trying to do the disk/washer method. Same thing. What we start tomorrow is the shell method. So problem 33 has 4 parts to it. I did that with a PowerPoint. So you're getting essentially 4 PowerPoints for washer and 4 PowerPoints for shell, that they're there to prompt you. So we're going to go to problem 2011, number 3, part C. So I want you to find it. You go to the link in Canvas. 2011, 3C, I'm here. You scroll down. You have to go below the 2019 questions. Once you get back that far, 2011, there is the questions and then the Form B questions. There are two different sets of questions. So I want 2011, question 3, no calculator, part C. No, I don't. All right, so if you're at home, sorry for the confusion, we are at 2006, Form B, 1B. So on Friday, we did this problem, A and C. Now we're coming back to B. It is a calculator question. We're just going to say if we have it set up right. So you should have this, pi big R squared, subtract little r squared, dx. So I would have f of x, which is the function you were given, which you're going to put in your calculator as y1, whatever. And you're reflecting it over this line, y equals -2. So the upper take away lower. So it'll be this curve, take away a -2, which is this curve plus 2. Subtract the -2. Squared, subtract the inside radius. The inside radius would be 0. Subtract the -2. Can you see that? So this comes out at you. The inside radius is the axis. Take away the -2 because you're reflecting over the line y equals -2. So this is what you should have. And what are the limits? Well, the limits are the limit in A when you second trace intersected where the curve hits the x-axis, which we use that limit on the A solution. I'm not really, you go the second trace 0 it, 2, 0. Okay? So you have to have that. If you don't have that set up, then what you're doing is going to take you to the wrong spot.
Why is little r 0?
Because it's the inside radius. Little r is not 0. Little r is 0, subtract the -2. Because if we draw this picture, like here's r. Yes? And you're reflecting over this line, y equals -2. So it's coming down here like that. And you have this gap in there. So the outside radius is, like the radius is the blue curve, take away the -2, which is +2. And the inside radius is 0 subtract the -2.
Why is it 0 though?
Because that's the axis.
Oh.
Like when you bring this all the way down, the hole in this curve is symmetric to -2. But the curve, R, stops at the axis. The curve doesn't go into quadrant 3. The floor for the curve is y equals 0. All right? So, 2 minutes to go back to what you're doing on the calculator, because you need the calculator to get the numerical answer. And we're going to go over this. If you're at home, ready? We're going to go over this answer without you. You can look at the answer solution, because right now, if you're at home, you're dismissed to go do the exit ticket on AP Classroom. So here's that problem. We go to y equals, we type in the function. We go to graph. We second trace 0 this. That value is stored in x, so that's our lower limit. From x to 0, big R squared is the function, subtract a -2, same as +2 the quantity squared, subtract 0, subtract a -2, which is subtract 4, 2 squared. Yes, 2 squared, so I just wrote 4, times pi, and that is the volume of the curve. That's 2006 B, number 1B. Okay.